Okay, so this is the rest of section 5.1, and what we're going to focus on here are imaginary numbers. So what you noticed on the other lesson is we ended our lesson with this concept of the square root of -1. So if you think back of where we ended over here, we have this square root of -1. And whenever we have the square root of -1, this is going to be a special variable, and this variable is I. So if I look at this chart over here, if I have I, just I, or I to the first power, this is the same thing as the square root of -1. Well, if I square this, and we know what happens if we square something. So if I have a square root and I square this, we know that we get rid of the radical. So in this case, if I have I squared, it is just -1. And then if I take I cubed, this is the same as I times I squared. So if you remember what we did with exponents last semester, we add exponents when we have the same base. So what this is saying is negative square root of -1. So I cubed is the same as -I. And if I have I to the fourth power, this is I squared times I squared. So if I have I squared is -1 times -1, we know that this is just a +1. All right, so then I go over here and I say I to the fourth times just an I. So I to the fourth is 1. So this is square root of -1, which is just I. And then I to the sixth would be -1. So you are not going to have to do all of this, because what you should see here is we start with square root of or I is the square root of -1, 1, -I, 1. And then we start over again and we have I, -1. And if I had I to the seventh right here, it would be -I. So really all you need to know are the first four. And that's what this says. What pattern do you notice? So every fourth term repeats. So the most important one that you need to know here is I squared, because I squared we're going to have to do something special. So just a little review on simplifying radicals. What we want to do when we simplify a radical is we want to find the greatest common factor that is a perfect square. So if I separate this out, what is the biggest perfect square that goes into that number? So for 24, it's going to be 4 times 6. 2 times 2 is 4. And I didn't write these down. You need to remember these from last semester, but if you don't remember, 2 squared is 4, 3 squared is 9, 4 squared is 16. If you don't remember all of these, you've got to go back. You've got to go back and learn these. So what I have here is that my perfect square that I pull out front is a 2, and what's left underneath the radical is a 6. But I also have this -1 that's in here. And because I have this negative, and I know that the square root of a -1 is I, I'm now going to pull the I out front. So this is my final answer. So if I look at -40, my perfect squares are 4 and 10 is what's left. So when I pull this out front, I get 2I. I is because it's negative, with 10 left inside the radical. With 75, 25 is my perfect square, 25 times 3. So I pull out the 5. The negative that's in the inside is my I, and I'm left with the square root of 3. Now this one's a little tricky. So the only two numbers that go into 21 are 3 and 7. Now neither one of those is a perfect square. So because this is neither one is a perfect square, I can't pull anything outside the radical except for my negative. So this one's going to be I square root of 21. And this is what my final answer would be. So what you see on all of these is we have a negative underneath the radical, but when we pull it out front, that negative goes away. It's no longer in the radical, and it becomes an I on the outside. Okay? Now, the great thing about this is we can simplify these expressions just like we would like terms if they were x's. So if I look at this first one, I know that the value of 36 is a perfect square, and that value is 6i. And if I multiply it to this perfect square, that would be 4i. So these are like terms. I'm going to go ahead and multiply those together. So I would have 24i squared. Now, we're not done because we know that I squared is the same as -1. So this I squared term that I have right here is going to go away, and I'm going to have 24 times -1. So this value becomes -24. And that's my final answer. Okay? Now, this is kind of tricky. So what happens here is if we have this power to the 82, we're not going to continue to make this pattern. We're not going to say, you know, I to the 7, I to the 8, I to the 9, all the way up to 82. That would be ridiculous. It would take all day long. But we know that it repeats after every 4. So if I take 82 and I divide that by 4, if I take, here, let me put this in my calculator. If I take 82 and I divide it by 4, then I get 20. Here, 20 is the whole number that I get. Sorry, there's a glare on my calculator. So this is 20. And if I have 4 times 20, it's 80. And I have a remainder of 2. We're going to look at this kind of old school division. So 4 times 20 is 80, but then I have 2 left over. I have a remainder of 2. Well, this remainder of 2 tells me the power on the I. So this is I squared. This 2 is the power on the I, and we know that I squared is the same as -1. So if I do another one, I'm just going to randomly pick one out. Let's just say I do I to the 74. I don't know. I just made that up. So if I go over here and I take 74 and I divide it by 4, I see 18. So again, what I care about is the remainder. So if I have 18 times 4, that's 72. To get to 74, have a remainder of 2. Just by chance, this is also I squared, which is -1, right? But if this would have been 73, then this would have been a remainder of 1, and remainder of 1 would just be an I. All right, so you'll have an opportunity to practice some of that with your homework. All right, now this looks tricky, but it's really not. All we're doing is combining like terms. So here we have a constant, and here we have a term with an I. Just think about it as like the same thing as an X. So if I distribute this negative through, I would have 2 minus 5i plus 3, because I have a negative times a negative, plus 8i. So if I combine my like terms, I have a 2 and a 3, which is a 5. And then I have 8i minus 5i, so plus 3i. Now, I can't combine them any more than that because these are not like terms. Okay, so you pause the video and you do number 8 and then come back for the answer. Okay, so here's the answer. -5 minus I. Now you can do a couple of different things here. You could say -I minus 5. You can change the order. You can also say -5 minus 1i. Now we don't do that, but this isn't wrong. It would be like if we said 5 minus 1x. That's not really wrong, but the correct way to say this would be 5 minus x, right? So it's okay if you left that -1, but you want to get out of that habit, okay? All right, let's go to the next page. All right, so what we're doing here is we're multiplying. So when we multiply, we're going to distribute. So my first term becomes -2i. I distribute to this one. I have 2 times 3, so plus 6i squared. Now, we're not done because we know that I squared equals -1. So this guy is going to turn into a -1. So I have -2i minus 6. So I take this I squared, I replaced it with -1. 6 times -1 is -6. Okay? Over here, I have a perfect square. So if we remember with a perfect square, this is going to become 9i minus 10i. So 9i minus 10i is just -i. All right. Now, exponent rules stay. These are the same exponent rules that we had last semester. So the power here is only on the I, Power here is only on the I. So we don't do anything to the 5 or the 8 except for multiply those together. It would look different if it looked like this. Here, the power is on the outside of the parentheses. So if I multiply this together, I get 40i to the 7th. Now, I'm going to go over here and I'm going to say 7 divided by 4, and that's 1 with a remainder of 3. 1 times 4 is 4, plus 3 is 7. So if you remember, based on our chart right here, that becomes a negative I. So this becomes 40 times negative I. So simplified is negative 40i. Let me go through this one more time. So it ended up with this power to the 7. I want to reduce this power to the 7. So if I divide by 4, I get a remainder of 3. So this is the same as saying 40i cubed. So 40i to the 7 is the same as 40i cubed. And I know that my I cubed is negative I. So when I reduce this I cubed, I make it a negative I. Now it's not subtracting, it's multiplying, so that's why I pulled the negative 40i out front. Okay? All right, next thing that we have here is foiling. We can foil with i's. So if I foil here, I have a 7. Foil here, plus 14i. I go in here to the middle, I have 2i, and then I foil to this last term, and it would be plus 4i squared. So I combine like terms now. And what we know about I squared is that this is negative 1. So this is 7 plus 16i minus 4. 4 times negative 1. So when I simplify this out, I would get 3 plus 16i. Okay, now what we're going to do is we're going to look at another way to solve. So this is kind of another concept. So we said over here at the beginning of the lesson, we can use the quadratic formula to solve if we can't factor. But what you notice on this is I have an x squared term and I have a constant term. Now these constants aren't combined, but I can combine those. So what I'm going to do is I'm going to move this 11 to the other side. So I'm going to subtract 11 from both sides, and I end up with 2x squared equals negative 48. And my goal here is to get the x by itself. Now I would have moved this over and set it equal to 0 if I had this middle term, this b term. So if I had the b term, then I want to follow this quadratic formula. But because I don't have an x, I'm going to use this method here that we're going to call square root method. So my next step is divide both sides by 2, and I get x squared equals negative 24. All right? So we know this. We did this last semester. To get x by itself, I'm going to take the square root of both sides. So this side is simple. It becomes an x. And now what you notice is you have a square root of a negative number. Whereas last semester we said we can't do that. Now we can do this. So we know that 24 has 4 as the perfect square. So when I pull my value of 4 out, I would get 2. Pull out the negative. What's left behind is a 6. So here is my final answer for this one. All right, let me do one more, and then I'm going to get you to do a couple of them. So I'm going to subtract 33 from both sides, and I get 5x squared equals negative 30. I divide both sides by 5 because I want to get x by itself. So I have x squared equals negative 6. Next step, oh, sorry about that, guys. Next step is I take the square root of both sides, and this gives me x equals I square root of 6. Okay, go ahead and pause the video and do the last two, and then come back and check your answers. All right, y'all. Here are the final answers on this. So this one's pretty simple. 10 doesn't have a perfect square that goes into it, so the only thing I can pull out is the I. Over here, When I simplify this all the way down, I get negative 8. So I can pull out a 2i square root of 2. Okay, that's it.